Thanks. Before I get started, I wanted to make a small community announcement. So we are starting a PyData meetup in Paris. So if any of you actually lives in the area and wants to come or advertise the event, just check it out and retweet and help us advertise it. So for this first event, we're actually going to have Travis Oliphant, who is the creator of NumPy and the CEO of Continuum Analytics, as well as Gael Varrocco, who is the core developer of scikit-learn, the main machine learning library in Python. And I'll be emceeing this event as one of the main developers of Jupyter. So now, actually, this talk is mostly going to be about live demos and interactive, so I won't be using slides. So I'll get started right away with interactive in interactive mode. So please feel free to interrupt me and ask questions as I'm presenting. But before I get any further, I wanted to get a grasp of how much of you know about Jupyter or use Jupyter in their work. Okay. And who has never used or seen Jupyter before? All right. So maybe since there are some people, it's not usual that people have not heard of Jupyter before. So I'll probably come up with a few slides introducing what it is and what it's about before I get to the actual demo. So slideshow. There you go. So Jupyter is a set of library and tools that are meant for interactive browser-based computing and meant to facilitate the workflow of researchers, and data scientists, and engineers at multiple phases of their work. So at the exploratory phase, also for doing the actual work and building the system that they are relying upon, and also eventually to present their research and publish it. Most of the time, if you are such a professional or a researcher or an engineer, you actually are using a very heterogeneous set of tools to do that. You have a complicated tool chain, and actually tracing back the origin of a plot that you got in your master thesis to the original code that generated it is pretty hard, because you have used a different tool to generate the data, and another one to serialize it into the proper format that your plotting can take, and then you inserted that into a report in LaTeX, right? And that workflow is very, very difficult to reproduce and makes science even worse, very difficult to reproduce from peer-to-peer, but even for yourself a few years later when you try to retrieve your work. So the main tool of that ecosystem and the most popular is the notebook. So it's an interactive browser-based computing environment that's mostly used for data science, machine learning, visualization. And it's also a standard in that it's a document format that can store code, narrative text, equations, images, and interactive visualization. And more importantly, it's also language agnostic in that it works with over 50 languages and is enabled by an architecture that is completely agnostic to what language is actually going to run the code eventually. So the whole thing is open source, it's BSD licensed, and so you can try it out, check it out on GitHub. So this is a very simple example of interactive notebook, where you see some code, some visualization inline in a document format. So where are we today? So in 2015, IBM conducted a survey of the users and estimated that we had around 3 million users in the world. And the main category of users of the Jupyter Notebook and Jupyter at large are data scientists, which are a fourth of our users. And other categories are students, scientists, researchers, developers, engineers, educators. So it's used in many areas of scientific computing, from teaching to actual hardcore science, and also very practical real-world applications for data scientists. So the notebooks can also be rendered on GitHub. Currently, so as of early 2017, there was over 500,000 notebooks on GitHub, so which shows the popularity of it. And we also enabled some really groundbreaking science that was using these technologies. So the fairly recent one was the LIGO project, which actually was the first actual physical observation of gravitational waves. So if you are into physics, this paper about how they measured and were able to observe that thing, the gravitational waves, that was a theoretical hypothesis up until it was actually observed. It's probably going to be one of the most cited physics papers in the 40 next years. And their research and all their computations and their plots are all available on GitHub in the form of Jupyter notebooks so that anyone can actually run it and try it and tweak it and change and try to reproduce the results. So in terms of reproducible research, it's a huge progress. But it's not only used in science. For example, BuzzFeed, which is not generally known for like the best journalism, it's because it started with some like the best 10 movies that are the 10 most underrated movies or things like this, but they actually are also doing a lot of journalism today, and they have an awesome data science team that publishes all their research and all their notebooks that back the different data journalism articles that they do in on GitHub, so you can check it out. But more than just notebooks, as I said earlier, Jupyter is a set of tools that work well together, implements the same protocols and file formats, and it comprises, so the notebook that you've seen earlier, a file explorer, a text editor, a console, all of these tools that are actually useful and necessary in the day-to-day life of a research engineer. So actually, we identified that there were at least 6 building blocks that was necessary for in your work, and the notebook was just one of them. So the file browser, the terminal, the text editor, the kernels, which are the part of the architecture responsible for executing the code, and also this output area, the place where you visualize the results of your computation. So yeah, I'm going to drop that. So what are we hearing from users? So most of the users of the notebook use it all the time. They use it in their day job all day long, and they love the notebook workflow and user experience. But there are some needs that they have that we have not satisfied so far. So first, they want a better integration with version control systems. They want an improved code editing experience, and they want a more flexible layout and integration between the building blocks that I listed earlier. And we're also missing things such as a debugger, profiler, variable editor. So people love the UI, they love the interaction of the notebook, which is better than most IDEs, but it doesn't quite get there, right? So that's why today I'm going to, before getting into the interactive visualization, introduce the new front end for Jupyter, which is Jupyter Lab, already available as an alpha product, which you can try and install from Anaconda or PyPy, but will be released at 1.0 before the summer. So what is Jupyter Lab? Is it an IDE? Yes, if by IDE you mean interactive development environment. Because most people who use Jupyter don't use it as a replacement for Visual Studio or PyCharm. They don't use it to build large systems. They use it at 2 phases of their research or their work. The first one is at the exploratory phase, when they are trying to ask a question and learn something from the data, and also for presentation. So what matters is the interactivity more than an IDE of the scale of Visual Studio, for example. So Jupyter Lab also offers a flexible UI for assembling all these building blocks of interactive computing that were previously in different tabs of the browser. And it has also a modernized JavaScript architecture based on NPM Webpack and a plugin system that allows you to extend the system. So it's built upon a new framework for JavaScript, which is not React, It's Phosphor.js, which was built for this purpose, for the purpose of Jupyter Lab, of building such a complex application. And everything is open source as usual. So it's an early preview of only. It's not suggested for general usage compared to the classic notebook. And 1.0 is going to be released probably before the summer. So now I'll get to the live demo. So let me tell you a little bit about myself. So I'm an applied mathematician originally. I work on probability theory and continuous time stochastic analysis as a quant for Bloomberg. And so I'm a scientist, like most of the developers of Jupyter. And that's probably what made Jupyter so useful, is that it was actually built by the people who were using them. I'm also a quant, an adjunct faculty at Columbia and NYU. And a few months back, I actually moved back from New York City to Paris and founded QuantStack, a company that today only has a few, like 2 people, and we're working on scientific computing in C++ and Python. So as an open source developer, I'm a co-developer and steering committee member of the Jupyter project, and also the co-author of the Extensor C++ Tensor Algebra library, and contributor and co-author of the different visualization libraries that you'll see today. So now, what about Jupyter Lab? This is what you're seeing right now on the screen. Instead of the classic notebook, when you launch Jupyter Lab, here's what you see. You recognize something that really looks like a desktop application. You can already recognize some of the components that you would see in a classical IDE. So on the left-hand side, you've got a file browser, and in the middle, some splash screen with activities that you can launch, right? So right away, you can start with a new notebook that you would create. And here you have a UI that is very similar to the classic notebook, which was a one-page application in the past, just one tab with the notebook in a linear fashion. So for those who don't know about the notebook, the notebook is, I would say, an implementation of literate computing, in that you can mix and match and mix together code, text, and rich display. So for example, I can type some code and check that 1 + 1 is still equal to 2. I should probably zoom in. Or write some rich text and say that this is a cool paper with an even cooler subtitle, and start writing some LaTeX. And there you go. You've got some text, rich text, with interactive code that you can execute again. Or now you can start plotting stuff inline in the notebook, right? So let's say import matplotlib. So this one is a Python notebook. Maybe we have notebooks for other languages. And let's plot a sine function. There you go. And now we have a paper with some executable code, interactive text, a plot, so everything you would need to do science, right? So this is a classic notebook. This is the experience that people would use. And what made Jupyter so popular, it was this one-page experience where people could just type code in the browser and execute it either locally or remotely. So where Jupyter Lab comes into play is that now you can extend that with first a flexible layout. So I can move tabs around and arrange my layout in a richer fashion. Can open, for example, a terminal and say, and explore what are the processes that take the most resources at the moment, and move it around so that I can still execute and see the notebook. Run a new console. Launcher console. And now I have a more classical console type application where I can type some Python code. I can also connect that console to the same kernel and the same execution environment as the notebook. So it's really getting closer to a classical IDE experience with multiple tabs and a richer layout than the classical notebooks. So that is for Jupyter, for Jupyter Lab. It's not really the main item that I wanted to present today, but I just wanted to give the context about what we're doing here. So science in the browser, using like a document that you can share, the notebook, with interactive computation, graphs, and rich text. Also, this new architecture for the front end allows you to, for example, open a text editor to edit, let's say, a Markdown file, open the very same Markdown file in a different tab, but with a rendered Markdown. And both of them are actually reflecting the same model. So now I have probably a very convenient Markdown editor saying that I am going to, let's type some more content, and I will see this reflected in the rendered Markdown on the side. You can also render images, so even animated GIFs, and same as usual, like move it around in as a separate tab. So yeah, that's about Jupyter Lab. And now let's get to the cool stuff. Not that Jupyter Lab is not cool, that's not what I meant. It's really amazing, but that's not really what I was going to talk about originally. So, as I said earlier, people who use the notebook and Jupyter most of the time don't use it to build complex systems for which they would use a classical IDE. They use it because they want to have an answer to a question. It's an interactive computing environment. They are doing some research. They have a new data set that they want to interactively explore, visualize, do some scripting. And they eventually, when the code base starts to grow, they move to another environment, like an IDE. And at the very end, they will use the notebook again as a presentation and a way to display and showcase their work, right? So what the notebook does is something really simple. For example, in this cell, where I type 9 times 9 to get 81, what's really happening is that when I type 9 by 9, I am actually editing the document model for the notebook, then sending a message back to the backend, which may be on a server or like running remotely, that will execute my code, send back a message with the result of the code that will populate the notebook model and be displayed inline in the notebook and print 81. So even though that whole loop, which is called the read eval print loop in many cases, seems very complex and involves many moving pieces of architectures, it's really fast. And when I want to test that thing with a new number, actually I am the bottleneck typing the code. So you may want to find something to replace that bottleneck with something faster than you typing and changing the parameter of the square function as you want to explore it, right? So instead, you could write a function and say, OK, now I only have to, of course, to modify one number in the code, but still it's not enough, right? And then you can decide to use something much faster, even than using a function, is having some small graphical component inline. And here I'm just using a slider to explore the behavior of my f function, which is just a square here. So what's happening now when I type interact of f with x is equal to 0 to 100 is that I'm using the introspection features of the Python programming language to explore what are the parameters of f and replace and interpret the tuple 0, 100 as an abbreviation for a slider from 0 to 100. And here's what I get. So, but instead of just using the interact magic that does all this introspection for automatic GUI generation, you can directly instantiate widgets on the fly and wire them together with in the following way. So let's say, for example, that I declare a new slider. So slider is an object of type float slider, which has a number of attributes. So a value of 7.5, a minimum of 5, and a maximum of 10. And now, when I display that thing, the notebook is going to render that object as a slider, obviously, right? If I display again the same object, I get the same visualization. And these two views of the same model are synchronized with each other, right? When I read the value from the Python side, I can use that, so use that input that I made from the JavaScript, from moving the slider graphically, or I can also set the value to manually, and here I set something too small, so 5.5, and see it reflected in the front end. So even though the slider is not really that fancy, it already has all the features of most of the widgets that I'm going to talk about, which is bidirectional communication. On the one side, you can interact with something graphical in the front end, and on the other side, you can modify that object by just typing Python and see this change reflected in the slider. And here, I'm just wiring a slider and some box which displays the same number, right? So what's really happening here is that whenever I instantiate that float slider object, which is a Python object, it gets automatically synchronized with a new object, which is a counterpart in the front end, which is a widget model. And every time I display it again in multiple locations in the notebook, we have a new view object that is going to be that visual representation instantiated. And they all reflect the same state. So more importantly, what I wanted to say is that, well, we have a bunch of widgets. We have accordions, boxes, buttons, checkbox, color picker. But more than a set of widgets and a collection of core widgets, IPyWidgets is a framework upon which you can build and do really more fancy things than just checkboxes and sliders. So this is where I'm going to. So the first one I wanted to talk about is BQplot. Hold on. So yeah, there was a cell earlier there that got deleted. All right, sorry about that. So what's BQplot? BQplot is a widget library built upon IPyWidgets that was open sourced by the quants of Bloomberg. And they built it for themselves originally as a tool to better explore the data that they were using in their work. So let's hold on. I'm going to have to restart that. There you go. So I'm just generating some data, and BQplot is just a 2D plotting library as you would expect one to behave. So I generated some random data in the beginning, and now create a new figure with that PLT API, the byplot API of BQplot, which really looks like and feels like the one of Matplotlib. And when I do plt.plot xy, what I get is what I expect, a line chart, right? But unlike the earlier plot that you saw, which was a Matplotlib image, now I have something that is interactive. So I can just pan and zoom on the figure, download it as a PNG image. Everything works as expected. Obviously, we have other types of plots, histograms, histograms, scatter plots, and everything. But more importantly, in BQplot, every single item of the plot that you're seeing is just like the slider. It's an independent object that you can update from the backend or the frontend and see reflected across the wire of the JavaScript to Python interface. So for example, here, I am actually explicitly building a plot from all the components that make it from all the components that compose its object model. So first, I generate some data, then I create some scales, which are the transformations, the mapping between data and some visual quantity. So here I've got a y scale, which is a linear scale. I've got an ordinal scale for x. I create some axes, which are visual representations of this mapping. And eventually, I put a few items on the chart, and here is what I get. So every single component of a chart is a different widget. So for example, here I've got 2 lines, and as I set line.y is equal to a new value, it's going to be reflected in the visual presentation of that widget. And I can run this multiple times and get the chart to update, just because I update the y value of my line chart, which is one widget among many in that plot. So the same holds for pretty much anything. So here I'm doing the same thing with a scatter plot, so changing the values. Or I can change the minimum value of one of the scales. So if I set the minimum of the x scale to 4, it's actually going to modify the entire figure. If I set it back to none, it's going to be computed from the data again. So, or like change the figure axis, the legends, everything can be set on the fly, and you can work iteratively to build a more and more complex visualization, just by typing things one by one and experimenting and doing very quick back and forth. So more importantly, BQ plots can be wired with other widgets. For example, here I'm just modifying the angle of a scatter plot based on the rotation parameter of a scatter plot based on the position of a slider. Or you can use BQ plot figures as input widgets. So one very common and important way to use a plot as an input widget for someone who works in finance is to select intervals of dates. So it may sound stupid. Most of the time, people would just use a brush selector from X to X1 to X2, and they'll have to click multiple times just to do that operation. So here, what I'm doing is by just clicking the middle of the figure, I get an interval right away. Moving the mouse up will widen that interval, and moving it back down will going to shrink it down. If I move the horizontal position of the mouse, it's going to move the center of that interval horizontally. And obviously, the selection itself is just like the slider. It's an object that can be modified and seen from the Python side. And here, I'm just reading the selected values from my line chart in Python and can react to that. I can make other plots update as I select an interval in my figure. Another way to interact with a figure is just, for example, to draw. That may look a bit silly, but let's say that you have some fancy machine learning model and you'd like to see how it behaves with some new curve or new input, right? What you would do most of the time is try to make a new function look like what you want by composing some sines and cosines and exponentials, and like basic functions to make it look like what you want. Or you could just draw it in BQplot and see it reflected right away in your model. So you can hand draw, select, or move points around. Here it's a scatter plot. I'm moving the points of my scatter plot around. See the mean that is computed in the backend, that is computed by the Python side. On the Python side, reflect that new quantity. So just to display that you can build more complex applications with BQplot, we actually used it to reproduce the ever popular Wealth of Nation visualization, which is an animated visualization of a data set, which is the income per capita. I don't know why this didn't start. Live demos. So it's a visualization of the. Let me try this here. I don't know what happened here. Let's hope this works. There you go. So of the income per capita with the life expectancy for a number of countries. Oh, you don't see the backgrounds of the plots, right? It's very bright. So anyway, you have actually grid lines in the background that are not visible because of the brightness of the screen. So in this example, you actually see the income per capita, life expectancy, and population in a bubble chart. If I hover on like the biggest country here, you'll see that you don't see that. It's actually China, so with a tooltip that you can see as you hover. You can pause the animation, or just use the slider to modify the current year. So building an application like this, if you had to write all the JavaScript and yourself, would be quite complicated. While here, just writing a few lines of Python gets you pretty far. So what happened earlier? All right, let's hope that this works. So the second library I wanted to talk about after bqplot is py3.js. So while bqplot was a set of bindings for d3.js, py3.js is a set of bindings from Python to 3.js, the WebGL visualization library. So in this example, I just, so it's a pretty low-level thing. So you can, the way you assemble a 3D visualization is by setting up the position of the lights, the camera, the different objects that you'll have in the scene. And by doing all of that here, I just created a very simple surface plot. So with an interaction which is a picker in 3D. And you can modify the actual values on the fly. Everything in this scene is a widget and synchronized between the backend and the frontend. Or you can also use it to display and visualize some parametric functions. More than just a static visualization thing that you can rotate and all, py3.js allows you to, since it's based on IPy widgets, to wire these widgets with other widgets of the ecosystem. So for example, let's say that you have some ideas on how to make changes to that parametric surface, right? So in this example, I parameterize this with 3 new quantities, shape X, Y, and Z. And with just moving sliders, you get a faster and greater feel on how these parameters will impact the actual shape eventually. So as I said, this would be fairly difficult to do if you had to modify these parameters in the code, regenerate your visualization every time. Using IPy widgets and Jupyter, you get a much faster iteration through that read eval print loop, right? It's much faster to modify to move a slider than just set the value from your Python code, obviously. The third important library that was built upon IPy widgets is IPy leaflet. For those of you who don't know about it, so leaflet is a very popular mapping library in JavaScript that allows you to create maps that sort of look like Google Maps. So by just importing the right things and saying map, m is equal to a map, and displaying the map, I get like an interactive map of the Jacksonville area in the US, right? So here I'm going to do something that I didn't display earlier, but which could have been done with pretty much any widget, is grab that thing and put it aside in a different tab of Jupyter Lab, right? And now I'm going to edit that thing. So, sorry. So here I downloaded some GeoJSON data, which is a common format for geographical data sets in JSON. And I created a new GeoJSON layer that I'm just now adding to the map. And these are some ISO lines of the terrain elevation in this area. Everything in this is a widget. So again, I can wire the zoom level of my map with some value of a slider, and see it reflected as I move the slider. So it's very easy to build some complex applications using IPyLeaflet and other widgets without having to do know anything about development in the browser or anything like this. So it's really good. Oh yes, before I move on to another plotting library based on widgets, I just wanted to show this thing. So IPyLeaflet was not something we worked on in the past up until we had to participate in this hackathon in San Francisco. And so we unearthed some code that didn't work anymore in IPython at the time, and during the hackathon made IPyLeaflet work again in Jupyter and built this application where you can visualize the level of satisfaction of people in different neighborhoods of San Francisco and see the actual factors from the data we got on the different neighborhoods from the national survey and the census, national census, and surveys that were done among the inhabitants. Let's get back to some GIS example. So earlier, so I showed you Py3.js, and here I'm going to show another example of use of the Py3.js library with some GIS examples. So I downloaded some terrain elevation data from the Grand Canyon and visualized it as a 3D surface here. And there you go, you've got the Grand Canyon. So sadly, you don't quite recognize the Grand Canyon right away because the camera position is not the best one. And in order to move this around, you would probably need to modify 6 parameters, right? You have X, Y, Z for the camera, and also the vector that is defining the direction in which you are pointing, right? So adjusting the camera position is possible just by modifying the value, so position and look at. But in doing so, I still need to do quick iterations to find the right values to get the visualization that I want. So again, I find myself being the bottleneck in this read eval print loop between me and the actual execution of code, right? And even though the backend is doing something quite complicated, which is to compute some 3D visualization. So I could use some sliders and try to move the camera around by changing X, Y, Z. So this is already better than changing the values by hand, right? It's not great. I mean, we have all been playing video games, right? And we know that there are better ways to move a camera around in a 3D environment than just moving sliders, right? So what I did is that I made a gamepad widget, right? So there you go. I import controller from IPyWidgets, say pad is equal to controller, and display that new widget in the notebook. And what it says is connect gamepad and press any button. So there you go. I've got my Xbox 360 game controller. Press a button. And now I have an interactive widget reflecting the state of my gamepad inline in the notebook, right? So this is displaying like the actual brand of this controller and the different values for all the buttons, right? Even the trigger buttons give like an intermediate non-integer value. Whoa, what just happened? No, it's on. I don't know what's going on. I'm plugged in, but maybe not. So the charger was not working. Yeah, it seems to be good.
It's back.
It's back. Not on the screen though.
But it's like 10%. It's charging now.
Yeah.
That's fine.
Yeah, it's up. Awesome. So But as usual, every single item that you see on the screen is a different widget. So for example, the pad.access.1 itself is a separate widget. I don't have like a single widget for the entire gamepad. It's a compound one, right? So I can just visualize it separately and access its value from the Python side, right? And here I see that it's minus 0.84, right? At the time when I actually read the value. So let's do one thing very simple. I'm going to wire these values with links between wires, so the positions of my axis to the position of the camera, right? So let's do this. There you go. And back up. And now I have almost a flight simulator in 20 lines of code, which I think is pretty awesome. So this is a spectacular example. Although what I think this really displays is that by doing very simple operation, like saying, oh, here's a slider, I just wire the value of the slider with this other quantity in another widget, and I compose all of that in some layout in a very literate and direct way without doing any like fancy architectural code, right? You can get you get something that is fairly empowering, right? You don't need to know much to do things that were very complicated to do some time ago. And this is really what I think interactive widgets of Jupyter bring, right? We got some quants who had never written any Python and were just MATLAB users. And their first Python program was written in the notebook, and it was a complete web application with multiple charts updating and interacting with the mouse position and dancing lines all over the screen, reflecting some fancy model that they were using in the backend. And to get from nothing to there in a few days while not knowing the language really shows how widgets can help you do better work as a data scientist. And now you get to play with Xbox controllers at work, so it's great. Before I get to the gory details, I wanted to mention another plotting library, another visualization library that's been built upon IPy widgets. Even though I am not one of the authors of this library, it's called IPy Volume. So it's a newcomer in town, which was written by Martin Brothers, and doesn't work. Sorry, hold on. That's the live demos, right? There you go. And it's a library that is really quick and efficient at making three-dimensional scatter plots and volume visualization. So in this example, I just use the quick scatter function, and I get a super fast and easy to move around scatter plots using some spheres as a marker. Also, it's got this super cool feature, which is that you can put it on full screen and then use a stereo display to have this on some virtual reality device. So that is pretty nice. And all of this in line in the notebook, right? Another thing, you can also use different types of markers. So here I've got two scatter plots on the same figure with different colors, and just changing the size of the different markers allows you to visualize these two things separately, right? And you can change the color interactively and see it reflected in your plot. And another thing that it can do is animation, although it seems that I deleted the cell, so I'll show it later because I have another one coming up. Yeah, BQplot, 2D plotting, Py3.js, 3D scene visualization, IPy leaflet for maps, IPy volume for volume visualizations and 3D scatter plots with animation. So you've got a pretty comprehensive ecosystem built upon IPy widgets. So, as I said, it's an ecosystem upon which you can build. So if you are interested in building your own widget that would be based on some fancy JavaScript library that you know about and hasn't been bound to Python, you can get started pretty quickly using the cookie cutter template project. So before I get any further, does any of you know about cookie cutter? OK. So cookie cutter is a template for projects. So some person wants to facilitate your life writing a new Python project that has some boilerplate for, let's say, a widget or a Jupyter extension, right? So we did all the work for you, and all you need to do is call cookie cutter with the URL of that Git repository, giving some parameters like the name of your project, the name of the Python module that you want to create, what is the name of the JavaScript module that is going to power the frontend. And it generates everything with some examples that you can start tweaking to get your code up and running. Because otherwise, it would be pretty complicated to get started. After all, interactive widgets have a front-end component in JavaScript. They have a back-end component. They have a kernel component. So you have 3 moving pieces that you need to write. And doing all the boilerplate and doing all the work to get this packaged and installable easily is not that simple. So with the cookie cutter, you can get all of that done for you, and then you have a working project that you can start modifying and iterating upon. So check out the widget cookie cutter, which embeds a few examples. And the first example is a hello widget. It's like the hello world of IPy widgets. And so, yeah, this is the way this works. You can also author such an interactive widget in the notebook. If you want to iterate, and once you get something that you like, you just start up the cookie cutter and copy-paste that code in it. So let's get started with a new widget, a new Hello World widget for Jupyter. So I'm first going to write the Python class that will power this widget. It's going to be a Hello widget. It inherits from a base widget that does all the magics for synchronizing with the frontend. And I have to define 2 parameters. One is the view name, so what is going to be the name of the JavaScript object rendering that thing in the frontend, and the view module, so in which JavaScript module is it going to find that piece of code. Also, now in the frontend, I'm going to define a new module, hello, which depends on Jupyter.js widgets, and does nothing for now. And now I'm going to iterate on this and build up my hello widget. So here again, I define my hello widget that depends on Jupyter.js widgets and create a hello view thing. And the first thing that hello needs to have is a render method. What is it going to do when the widget is rendered? And all I do here is say, oh, it's just going to write hello world in the top level element, right? So there you go. I've got a new hello module, depending on Jupyter.js widgets, defining a new object called hello view that inherits from our base view, and defining a render method that just writes hello world. So let's test it. And now I have a new hello widget that says hello world. Now I can make the widget stateful, right? And have a value that defaults to hello world, but which I can change from the Python to change the text that is displayed, right? So let's start over. In addition to the view name and view module, I create a new value parameter, which is of type Unicode and synchronized with the frontend, that defaults to hello world. Now, in the frontend, in addition to render, I am going to get the model value for the model value for the value parameter. And also add a change callback for whenever it changes in the backend. And there you go. I have a new hello widget that says hello world. And when I say w.value is equal to test, the widget reflects that new value. So once you've done a hello widget like that, you've done 90% of the work. Then you can start doing really fancy stuff. For example, if you want a data-driven pink rabbit, you can do it with whatever pink rabbit JavaScript library you find online, right? So let's do that. So last year, I was in a PyData meetup in Paris. and there was a D3.js tutorial. And one of the main items of the tutorial was to reproduce that example, which is a 2D Voronoi tessellation, where you could move the mouse around and see what would be the Voronoi tessellation of all the points in the original dataset plus the position of the mouse. And you've got this really fancy 2D animated Voronoi tessellation, right? How about we put this thing into the notebook, right? So there we've got all the JavaScript code that runs this example. So how about I just copy paste that thing and put it into render, right? And now instead of using some random points generated from, like that it is reading from a CSV, I'm going to get that from the Python side. And there you go. I wrote some CSS. Sorry, I need to import my code. I wrote some CSS and display my Voronoi tessellation. And every time I change the vertices, the new Voronoi tessellation is reflected. So here I've got what? 50 lines of code of JavaScript to produce that new visualization or new widget type that didn't exist before, making use of the d3.js Voronoi tessellation. And I have a cookie cutter project that I can use to package that into an actual pip installable package. It does everything for you from the setup.py to the Conda recipe and all of that. So which I think is really empowering if you've got some JavaScript skills and you want to make a new widget or improve upon a widget that already exists, such as bqplot, IPyLeaflet, or Py3.js. Yeah. So the last thing I wanted to talk about really quickly is about embedding. All of what I've shown so far was only running in the Jupyter notebook. So for example, you put together a super awesome 3D surface that is the result of some optimization that only you know how to do, and you want to share that thing with the world, right? Sadly, so far, the widget's only rendered in the notebook, and not everyone has the notebook. You may want to put that thing in an animated fashion in your blog, in the documentation of some package, in wherever you may want to put it. So actually, with the latest version of IPyWidgets, which is IPyWidgets 6.0, we enabled the inline rendering of interactive widgets in static web pages. So here, in this example, I create two things. So first, two sliders that are wired with each other. With one, the value of one is linked to the maximum of the other, and some scatter plot from bqplot, right? And all I need to do is click on widgets, hit embed widget, and I get a copy-pastable snippet of HTML that I can paste into any HTML page, your blog, whatever. So let's do that. I open some basic index.html file. It's got some boilerplate CSS. I paste the pastable snippet of code, and now when I open it, I see what I expected. The two sliders that I displayed earlier in the notebook, and a live 2D scatter plot, right? And this works with pretty much anything. IPyVolume, IPyLeaflet, Py3.js. So this is actually how we also power the Jupyter.org website. So if you go to jupyter.org/widgets, you're going to see actually a gallery of all the widgets library that were built upon IPyWidgets. So the first one, which was IPyLeaflet, bqplot, Py3.js, and IPyVolume, with this time a great animation of some moving scatter plot. And all of that runs in a static web page with no interaction with the backend whatsoever. It's all static content. So this was the last thing I wanted to show, and now I'm going to talk about the future. So we have released IPyWidget 6.0 a couple of months ago, and since then we've done a lot of progress. So with IPyWidget 7.0, the first item on the feature list is going to be the full support of Jupyter Lab. In that this platform that I displayed earlier, Jupyter Lab, is in a very alpha level in terms of at the moment. And we are probably going to have a beta release by the summer, by the SciPy conference. So by then, we should have the full support of Jupyter Lab in IPy Widgets. Another thing that new feature in IPy Widget 7 is binary serialization. One of the main issues that we had with these widget libraries was that it didn't scale very well when the data size was growing too much. And going binary is a way to mitigate that issue and allow much larger data sets, visualization of much larger data sets. Also, we have improved on the formal specification of the model schemas that, so that people who write kernels for the languages other than Python, such as Julia and R, can implement backends for the widgets. And naturally, we'll have some many bug fixes. So a beta for IPy Widget 7 should be available in the coming week. And later, so two things I'm especially working on at the moment. The first one is Xus. So Xus is just another misspelled name for Jupyter. And it's a C++ framework for writing kernels and applications with Jupyter protocols. So it will support the interactive widgets in native C++ code. And also, it will power a new Jupyter kernel based on the Clean C++ interpreter, which is a project from CERN. And also, the different 3D plotting libraries that I have displayed, so Py3.js, IPyVolume, are working together, and there's a lot of synergies at the moment to come up with a common solution that would be the way of doing 3D plotting in Jupyter in the future. And finally, there is a project that just came up on the Matplotlib organization on GitHub, which is IPyMPR. And IPyMPR is an implementation of a frontend, actually, oddly in Matplotlib, frontends are called backends. But IPyMPR is a new backend for Matplotlib, which is based on Jupyter Interactive Widgets. So that's it. Do you have any questions?
I have one. So
Yeah.
basically, you are not using Matplotlib anymore because that. Basically, you are using Matplotlib instead of Matplotlib. You are using your own solutions.
Yeah.
Because that would be only in Python and it wouldn't work with JavaScript.
So the issue with Matplotlib is that all the rendering logic is done in the backend. So even though it may be efficient, if you need to have some interaction, or if the backend is on a server that's not co-located with you, you're going to have a lot of latency in the interaction. So if you want to have this high interactivity, fast hit test on the position of the mouse, things like this, you need to have all the logics for the rendering in the front end. So that's why we created BQplot. There are some other competing projects around that are not BQplot, and BQplot is the only one that is based on the Jupyter Interactive Widgets and compatible, that offers that sort of interaction with Jupyter. Yeah.
These nodes will be available for us. I think I'm not.
So the question was whether the nodes will be available. Yes, it is already available. It's on my GitHub, Craft 2017. And in every notebook, there is a caption saying where to download all the dependencies to run that notebook at the top. I didn't show it here, but on the repo, it's there.
What was the name again? Yeah. The name?
Yes, I should write it down, actually. Let's write it in the notebook, right? So github.com. So that's not it, but that's Craft 2017. So here's a URL. So I know that there were a lot of moving pieces. But it's not that difficult to get into that code base. We've done a lot of work on documentation and getting started from both a user's perspective and also a developer perspective, someone who would want to write a new widget. And I didn't say it earlier, but there are some like really serious commercial products being built upon this. So in Jupyter at large, so we have obviously the Google Data Lab. There is also an offering with Amazon. And in terms of widgets, there is the Molecular Design Toolkit by Autodesk. There is NGL View, which is another visualization library for molecules. So lots of people are building upon this now. So the code base is getting like a lot of attention. Thank you.